Hello everyone and welcome to my channel. My name is Samir Kumar Patel and I am a student in the field of artificial intelligence and machine learning. Today I am excited to present my minor project which focuses on a fundamental and critical step in any data science workflow, exploratory data analysis or EDA. The main objective of this project is to perform a comprehensive analysis of a housing dataset. We will be using a popular housing.csv file which contains various features of houses and their corresponding prices. The purpose of this analysis is to understand the data structure, identify patterns, discover relationship between variables, and check any anomalies or missing data. This process is essential before building any machine learning models, as the quality of our data and our understanding of it will directly impact the model's performance. For this project, I will be using a suite of powerful Python libraries. First, Pandas for data loading, manipulation, and cleaning. Second, Matplotlib and Seaborn for data visualization to create insightful plots and graphs. I have divided this presentation into two main parts. First, we will dive deep into the data using Pandas and NumPy to inspect and manipulate it. Second, we will use Seaborn and Matplotlib to visualize our findings. So, let's get started with part 1, data analysis with Pandas. Alright, we are in our project environment. The very step is to import the Pandas library. We import it ASPD, which is the standard convention. Next, we need to load our dataset. I am using the pd.readcsv function to read the housing.csv file into a Pandas data file, which we call df. Now that the dataset is loaded, let's take our first look at it. Just by calling the data frame df, we get a snapshot. The output shows us the first few and last few rows, and it's the bottom. It confirms we have 545 rows and 13 columns. To confirm this dimension programmatically, we use the df.shape attribute, and as expected, it returns 545, 13. Now, what are these 13 columns? The df.columns attributes lists them all out of us. We have price, area, bedrooms, bathroom, and several other features that describe each property, including categorical one likes, main road, and funding status. To get a cleaner look at the first few entries, we use the df.head method. By default, it shows the top 5 rows, which help us get an immediate feel for the data values. Similarly, df.tail shows us the last 5 rows, which is good way to check if the end of the dataset formatted correctly and don't contain any summary rows or junk data. This next step, df.info, is one of the most crucial in any EDA. It gives us a technical summary of a data frame. Let's break down this output. It confirms we have 545 entries. Look at the non-null count column. We see 545 non-null values for every single column. This is fantastic news. It means our dataset has no missing data, and we don't need to perform any imputation or drop null values. It also shows the D type or data type. We have 6 columns of data type integer 64, which are numeric, and 7 columns of type object, which are categorical or text data. After info, our next most important command is df.describe. This method provides descriptive statistics for all the numeric columns. Here we get the count, mean, standard deviation, mean, max, and the quartile values 25%, 50%, 75% for a columns like price, area, bedrooms, etc. For example, we can quickly see the average price is around 4.76 million. The mean number of bedroom is 2.96, but the 50% or a median is 3, which is very close. The maximum number of bedroom in this dataset is 6, while the minimum is 1. Now let's explore how to select specific data. Pandas allows selection by integer position using ilog. Here df.ilog5 and df.ilog50 are examples of how to pull out a single specific row, the 6th and 51st row respectively, to inspect it. We can also slice the data. df.ilog 0gem5, 0gem3. Select the first 5 rows and the first 3 columns. df.ilog gem3gem select all columns for the first 3 rows, and the df.ilog 5gem14, 1gem5 select rows 5 through 13 and columns 1 through 4. This is incredibly powerful for creating subset of our data. We can also select data using labels with ilog. Here df.ilog 1gem3, bedrooms, basement, parking. Select row with the index 1 to 3 and the only columns I have specified by name. Next, I wanted to understand variety in our data. The df NUnique method counts the number of unique values in each column. This is very revealing. We can see bedroom has 6 unique values, bathroom has 4, category columns like main road, guest room and basement all have 2 unique values, which we can say assume are yes or no. Furnishing status has 3 unique values. To see the actual unique values, not just the count, we can call dot unique on a specific column. For example, df bedrooms dot unique show us the values are 4, 3, 5, 2, 6 and 1. Even more useful is value count function. Running df bedrooms dot value count show us the distribution. We can see that 300 house have 3 bedrooms, 136 have 2 bedrooms and so on. This is much more informative than just knowing there are 6 unique values. Earlier, df.info told us we have no missing data, but it is always good to be true. df.isNull.any check if any value is column is null. As you can see, the result is false for all columns. df.isNA.sum counts the total number of NA or null values per columns. As expected, the result is 0 for all. This command just confirms our data is clean and complete. We can also run calculation on individual columns. dfPrice.mean and dfPrice.median calculate the mean and median price of columns respectively. Notice the mean 4.76 million is slightly higher than the median 4.34 million, which suggests the price distribution might be slightly right skewed, but we will confirm that with a visual plot later. Just to demonstrate data cleaning, I have included the df.dropNA commands. If we did have null values, so we would remove them. Since we have no null values, running this and checking the shape against shows our dimensions are unchanged. Another important check is for duplicate data. df.duplicated.sum counts the number of duplicate rows. The result is 0, which means every row in our dataset is unique. Pandas also makes it easy to modify our data frame. df.drop bracket index is equal to 0, 1, 2 shows how to remove the first 3 rows. df.drop columns is equal to area and in place is equal to true. Demonstrate how to remove an entire column. Here I have dropped area and set in place is equal to true, which modifies a df directly. Now that we have dropped a columns, let's analyze one of our categorical features. df furnishing status value.counts show us the breakdown. Semi-furnished is the most common status, followed by unfurnished and then furnished. This is where pandas get really powerful. We can use group by. I have grouped the entire data frame by furnishing status and the used .get group furnished to extract a new data frame containing only the 140 rows where the house is furnished. We can then run analysis their subset, like finding the mean, max and mean price just for furnished homes. Finally, pandas allow us to manipulate the index of our data frame. df.setIndexPrice could make the price columns the next index. We can always revert this using df.resetIndex. And of course, we can sort our data dfPrice.sortValues and sorted dfPrice. Both show how to sort the prices in ascending order. We can also pass ascending is equal to false to sort in descending order. The apply method lets us perform complex operations. Here I have used a simple lambda function to create a new transform version of the price column, dividing each price by 2 and adding rupees to it. This demonstrates the flexibility of data transformation in pandas. That concludes our deep dive with panda. We have loaded inception, cleaned and manipulated our data. We have confirmed it is high quality and we understand its structure. Now let's move on the fun part, visualization. For the fun part of analysis, we will be using Seaborn and Matplotlib. First, we run pip install Seaborn to ensure the library is installed. Next, we import our visualization libraries Seaborn as SNS and Matplotlib.pyplot as PLT. We also re-import pandas and reload our housing.csv file. This gives us a fresh, complete data frame to work with, including the area columns are dropped in the previous section. As before, we check the shape, info and describe to refamiliarize our with this fresh dataset. Our first plot is a histogram of house price. We use sns.his hist plot on the price columns and set KDE is equal to true to overlay a kernel density estimate curve. This plot helps us understand the distribution of our target variable. As we can see from the plot, the distribution is right skewed. Most of the houses are clustered at the lower end of the price scale, which a long tail of more expensive house. This is very common distribution for variable like price or income. Now, let's visualize our categorical data. We will use a count plot for the funding status columns. This SNS.count plot gives us a simple bar chart showing the count for each category. Just as we saw with value count in pandas, semi-funded is the most common category, followed by unfurnished and furnished in the least common. Now, let's explore the relationship between in pivot analysis. We will create a box plot to compare the price distribution across the different bedroom categories. This box plot is excellent. Each box represents the interquartile range IQR for prices within that bedroom category. The line in the middle is the median. We can see a general trend. As the number of bedroom increase, the median price trend increase as well, especially from 1 to 4 bedrooms. The dot you see above the whiskers and outliers, these individual houses that are priced much higher than the typical range of the bedroom count. To look all the numeric relations at once, we use a pair plot. See SNS.pair plot create a grid of plots. On the diagonal, it shows the distribution of each variable. On the off diagonals, it creates a scatter plot between every pair of variables. This plot is dense, but it is powerfully diagnostic tool. For example, by looking at the scatter plot for price versus area, we can see a clear positive correlation. As the area increases, the price tends to increase. This is exactly what we did expect. Finally, to quantify this relationship, we will create a correlation heat map. First, we calculate the correlation matrix for all metric columns. Then we pass the matrix to SNS.heatmap. This heatmap is a fantastic summary. The A0 true argument prints the correlation coefficient in each square. The colors range from dark blue to bright red. We can easily confirm the stronger relationship with price. Area has a strong positive correlation. Bathroom and storage are also moderate correlated. Interestingly, bedrooms has a slightly weaker correlation than area or bathrooms. The diagonal is all one because a variable is perfect correlated with itself. So that concludes our EDA of the housing data. Through the power of pandas, we were able to load, insert and clear our data, verifying that we had no missing values and no duplicates. We understood the structure of our 13 columns and 545 rows. Then, using a Seaborn and Matplotlib, we visualized our data and uncovered key insight. The distribution of house prices is right skew, with most properties clustered at the lower end. The most common properties are semi-furnished. We confirm strong positive correlation between price features like area, number of bathrooms and stories. We also identify positive through slightly weaker relationship between price and number of bedrooms. This EDA phase has been incredibly valuable. We have a solid understanding of our data, its features and their entire relationship. This knowledge is the perfect foundation for the next step in a data science project, such as feature engineering and building a predictive machine learning model to estimate house price. This project was a fantastic learning experience in applying the core tools of any data analyst or machine learning engineer. Thank you so much for watching my presentation. If you have any question, please leave them in the comments below.